So step number 1, you need an access point, Wi-Fi access point. Now the Beagle Bone Black, this driver board here, this little computer here is called the Beagle Bone Black, and that's configured to automatically connect to the Wi-Fi with the name OSC HUTS and the password, which is in the documentation.
And how does one configure the network that the Beagle Bone is looking for?
You want to change the name and stuff? There's a settings file on the Beagle Bone Black, and you would connect to the Beagle Bone Black with the cable, with the Ethernet cable, which we don't happen to have handy here, but one that ends in this the RJ45 connector. Cat5.
Sure. Over here.
Yeah, you plug in over there, and you can then you have to plug in. Okay, the cable goes from here to a switch or a rotor. And then from the switch to the router, you plug in another cable, and it goes to your computer.
Wait, what's a switcher? Can we show that?
We don't have one here.
Okay.
But it's a switcher or router, so you can Google. It's a piece of networking.
Sure.
It's the same piece you were working with yesterday. And then you'll go to lasersaur.local. So you type that in your browser, and it'll do a DNS lookup and get you to log into the Beagle Bone Black. And then you need to SSH into the Beagle Bone Black. So like PuTTY is a good program for Windows. There's lots of other programs for SSH,
yep.
Secure Shell. And then when you're in there, you can...
I assume you can find the IP address from the router will assign that?
Yeah, the router assigns that automatically.
Okay.
And so you can either look on the router and find out what the IP address of the Beagle Bone Black is, or what worked for me, and this is the way it's supposed to go, is that you just type in lasersaur.local in your browser there, and it does a DNS lookup.
I see.
And it'll get the IP address automatically for you
from
the router. But yeah, looking up the IP address is a good backup plan if it doesn't work. So then once you're SSH'd into the Beagle Bone Black, there's a setting in a file which you can find in Lasersaur manual, and there may be a copy of it in the documentation for the torch table too, in that main documentation file. In the Dropbox folder right now. And so then you could use Pico or Vi or whatever it is to edit that file, and you just change the SSID and the password, and that worked fine for me. And then you can save the file, reboot the Beagle Bone Black, and it'll connect to the network with that name. It should be WPA2 PSK, so the security setting. And then, then after that you should be able to log into the Beagle Bone Black over the Wi-Fi.
Great.
So you get the network. So we've already done that part, and that's included in all that. In case you don't remember it or whatever, it's included in the documentation. And now I've turned my phone into a Wi-Fi hotspot. This is a standard feature in Android. Just go to the settings thing, and then you go more settings, tethering and portable hotspot. And then you turn on portable Wi-Fi hotspot. It's already turned on. And after it's already turned on, you again tap on the same area, which is not entirely obvious, and it'll open up the configuration for the Wi-Fi hotspot. So right now there's no devices connected, but it tells you the name of it. It says OSC HUTS. So allow all devices, of course. And you can go configure to set the password over here. Oh, I can't see the password. Okay. We should probably change the password periodically anyway. So now that part's set up with the Wi-Fi, and then I'm going to turn on the Beagle Bone Black. So first of all, we have to plug it in. Here's the power supply for it. It's a standard ATX power supply, and it's already wired up here. You can see the 5-volt positive ground. So we're sort of shimmying into the roll here. And so you can plug this in, and then we can also plug the step motors in. There's another power supply for the step motors. This is it. It's a 24-volt supply. So plug that in separately, and when you plug it in, the little lights on the step motors are on. And you hear the little clonk sound. Here, I'll do it again. Well, it's not as loud when you turn it off, and then turn it back on again soon after. So you can see the little light on you see the light over here on the step motor drivers. That's going to turn on. And, okay, now the Beagle Bone Black This is also another power switch over here. It was off, turned on. You can hear the fan turn on in this thing when you do that. And we got to give the Beagle Bone Black like a minute to boot up. It's pretty fast, faster than the laptop or something, but still got to give it some time. And we'll know when it's done, or sometime after it's done, because it should appear in the devices list. I'm going to get my computer to connect to that access point as well. So OC Hut's here. Just connect automatically. You should have the password in already. Takes forever.
Okay. So the Beagle Bone is actually in charge of activating the power supplies?
Well, you turn them on. What it does is it sends, you see these little connectors over here?
Yeah.
One of these goes to one of the stepper motors. And you can see there's 3 of them.
Sure.
Although it's only controlling 2 sets of stepper motors. How did that work? I don't remember how I did that. I'm going to have to come back to that one. Anyway. Okay, oh no, one of them is just like, doesn't go anywhere. Okay, but it's supposed to use a different stepper motor driver, the Geckos. But we tried to save money and use something else, because the Geckos are $70 and these are $20. These don't have any data sheets for them though. And they have a different pinout, so we can't just... The Geckos, this little header here, these pins sticking up, if you put your camera like down here, like real low, so it's like, yeah, you can probably see it there. Yeah. You can see those little pins sticking up, and this is called the terminal block header. It's, you tighten down each one of these screws and they connect to the pins that are right below them. It's got a little clamp on there, and then at the back here, this soldered on to the clamp is a wire. So this is just a way of connecting to the headers. But the Geckos just plug right onto those pins. And
I assume the Geckos come with their own schematics to figure that out.
well, you don't need a schematic for the Gecko, you just plug it in.
But to know which wires?
You don't have any, these wires don't exist if you're using the Geckos. They just plug straight into the board here.
Oh, I see.
Yeah, you can see that in, there's pictures of that in the documentation for the Lasersaur and also the torch table. They're just little red boxes. They look a little bit like this, but they're a little bit smaller and they're red. Actually, we can come over here because we have another drive board right here. Yeah, you can see exactly what it looks like right now. See, this is what they look like. So again, here's the pins that stick up with nothing plugged into them. And these are the Gecko drivers. These are the ones that you're supposed to use with the laser drive board.
Yeah,
and this is what it's designed for. And they work very well. They're great drivers, but they're $70 each to $20. So we just made these weird plugs and then ran the wires over to the other stepper motors, because you can't just plug them right in, because it's not the same number of pins, and the pins are in different places for different functions.
Okay.
Like this thing will send a step pulse, like one pulse every time it wants the motor to go in one direction or another, like one step, and there's 200 steps per revolution of the motor. And so it sends it to the driver here, and then the driver amplifies the signal into a nice power signal, and it controls the synchronization of the magnets inside the motor and stuff like that.
I see. So if someone was trying to set it up though with these cheaper, what are these stepper drivers called?
Yeah, you can just call them by their...
Got some model number. That's, yeah, sure.
Yeah, can you get the model number on here?
Sure. Yeah.
There's the model number there. So, okay, so like, yeah, that's how that's the
that's good.
The thing we did with the drivers.
Beautiful.
Now, okay, so the Lasersaur is booted up.
So, sorry, if someone was trying to take some of these drive boards and connect them to, so this is not part of the Beagle Black, right? This is a...
Yeah, like the whole thing is called the drive board, and then the Beagle Bone Black is a still computer here.
Okay.
And then there's an Arduino here. There's an 80 mega is the center core chip at the heart of an Arduino. And the Arduino like includes like the oscillator and some other design stuff around these other little chips here and stuff like that.
Okay, so what is this piece of hardware called?
For the whole thing altogether, like up until it meets the plugs here, that's called the drive board.
Okay, but like is there a model for this?
Yeah, there must be a model number for it. I don't know what it is though.
Okay.
I think it's, yeah, I don't know what the number is.
Well, I'm sure it's
You
documented.
could look it up.
Yeah.
We could figure it out. It's probably written on the bottom or something, but it's kind of hard to like turn this sit down right now.
Yeah, sure.
So, okay, so we look at the hotspot thing here. It says OSC2 is connected. That's laptop. Lasersaur is also connected. It's not called the drive board. It's called Lasersaur because, like, yeah, it's supposed to be built into a Lasersaur.
Right.
Now we go here. Just a second. Come on, Ellie. Now we're gonna go. What you're supposed to be able to do is type in again lasersaur.local. That's what it says in the manual for the Lasersaur. But my experience is this doesn't. Oh, it's doing something. Oh, it did work this time. Okay, well, it doesn't always work. So if it doesn't work, you just get the IP address of the Beagle Bone Black, which is, if you're using a different Wi-Fi access point, you're going to have some other way of figuring out what the IP address is. It's not always easy. So now I would just type it in 192.168.43.81. And it goes again.
Same thing? Okay.
Yeah. So it should load this page here. It says Laser App. That's a little JavaScript or Java applet that runs on your computer. So it's kind of interesting because it'll load even if you can't communicate with the Beagle Bone Black, because your browser stores the Java applet. Right now, okay, it says ready. It says so it's connected to the Lasersaur. It's in communication with it. If it's not, then that'll be like orange, and it'll say something else.
Oh, this ready sign here. Okay, sure.
Yeah, this ready thing here. Like if we turned off the Beagle Bone Black, it would turn orange in a minute or so. So if I go here, this is a good thing to do when you first turn it on to run the homing cycle. It should leap into action. There we go. So it did. What it does is it moves the step motor all the way until it hits the limit switch, and then it moves back like about a centimeter. So that's the noise there. Sounds kind of disturbing, but that's the way it's supposed to be. Okay, so now we can like. The next thing you can do just to make sure everything's working is this is the move and jog thing. You've got this rectangle here. You can click anywhere in the rectangle, and it should move to there. Okay, you can get it to move like at different speeds. Like this is in millimeters per minute. Then, and that actually is the millimeters per minute at which it's moving. You can use the arrow keys. You can like get it to go to a particular XYZ location, and like the air assist on off. Oops, I'm trying to scroll down by pressing the arrow keys. It just moves the. Okay, the air assist on off. That's for the Lasersaur. We're not using that. That has nothing to do with us because this computer still thinks it's using a laser cutter,
right.
Which is the machine over here. To further clarify, it looks. Explain.
Sure.
This here is the Lasersaur. This big thing here with all this. And it's got the power supply here. You can even see the laser in there. Here's the laser tube, 40 watt laser tube, CO2, and that's what it thinks it's controlling. This brain here, this drive board, we just took it out and we're using it for something else. It's just not really intended for. Okay, so then the next thing I'll show you is the Z motion control. Okay, oh no, shit. I didn't plug it last time. That's the battery's probably dead. Oh, fuck. The battery's dead.
Alright, so just put in a new battery from the smoke detector.
Okay, over here, it's the battery. Here's the battery connector. Kind of bugged. Now you can see the lights over here. If you want to bring your camera around, you can see the two status lights, which are good. If the battery's going dead, by the way, that little amber one goes kind of dim. That helps you know if it's dead. Also, if it sort of starts dimming when you press the buttons, then that means the battery's going dead. That battery's going to be replaced as soon as we...
Is that an Arduino Uno?
Yeah, that's an Arduino Uno, which is like the most basic Arduino you can get. Yep. Okay, so that Arduino, what it's doing is it's taking the input from these switches over here, and it's controlling the step motor.
This is the Z motor?
Yeah, this is the Z axis. So we've got a motor here connected to a lead screw, and that moves the torch head up and down. So I can move it up.
Oh.
I can move it down. So one switch goes up, one switch goes down. If you go all the way to the end of the travel, it'll sort of jam. There's no limit switch on the end of the... Yeah. So you kind of want to avoid that, although it's not really... There's nothing... What's happening is the electromagnet is trying to make the motor move, but it's not succeeding. So there's a vibration, but there's nothing actually wearing out. There's no metal parts moving past one another. So there's no wear. And if you go down too far, it's an interesting thing that happens. Watch right there.
Right here?
Yeah. That's the...
Oh, it screws up.
That's the nut. It's
Literally.
a little plastic insert, and it sort of comes out, and like, yeah, it doesn't always go back in again. But so like, I'm pretty sure there's supposed to be another one on the other side here, but there isn't. I don't know what happened to it. Probably got lost a long time ago. Or never installed them. So, those are all things that'll have to be resolved either the next prototype or sooner or later.
Yeah, I mean, it needs limit switches, but I guess
yeah.
the problem is the inputs on the drive board, right?
Yeah. Well, no. I mean, we can put limit switches to the Arduino here. For the longest term solution, yeah, that functionality that the drive board, or sorry, that the Arduino is currently implementing, that should be included in the drive board here. So that drive board is going to have, it's got 3 outputs for the step motors, right? 1, 2, 3. I forget one of them's doing, but one of those outputs is going to go straight to the Z motor. Well, straight to one of the drivers, and then from there to the Z motor. And then, so there's going to be another plug or two that looks like this on the drive board. Actually, these are, we can use these plugs here for the Z axis. Although we're going to need more for other reasons, we're going to need more. But yeah, so that functionality is going to be integrated into this board sooner rather than later. But it requires changing the software on the board.
Okay.
So
okay.
that would, it's not for now, anyway, because we don't have anybody on board who's like, you can do that easily, quickly. Whereas this is a good quick fix, so we can start cutting parts, and then experimenting with other parts of the system. Because it's not like just like getting us there, it's letting us learn and design the rest of the system, instead of waiting for somebody to do this part before we can move on. So it's like doing things in parallel. Okay,
So really quick, could you explain what you explained to me earlier about the the flow of from what happens when you are using the interface to where it gets turned into G-code and then read by the Arduino?
Okay, so to use this machine, you take an SVG file or a .dxf file. A DXF file is like easily exported from SolidWorks and other CAD software. It's like the standard file basically. And you'll import it into you go to the GUI here. The toolchain is this way. Click on File Import, and you got a button here on the screen. It says Import, and you click on the import, and it says supported file formats SVG and DXF.
DXF, right.
And then you'll go and you select your .dxf first, .svg file, and then suppose we go like this. We go test rectangle, add TQE, and then here you can change the feed rate. Now this is important because if the feed rate's too high, the torch isn't going to be able to cut that fast. So like a good feed rate, the equivalent, the torch is supposed to be able to cut at 40 inches per minute, supposedly. That's what the manufacturer says. But if I make it 30 inches per minute, that happens to be about 762 millimeters per minute, because these units are in millimeters per minute. And that laser power, that doesn't apply to us, that's not going to do anything. This is the color. The lines here, you can make them different colors in your .svg file. This doesn't apply to .dxf, because in DXF they're always the same color, I'm pretty sure. Maybe not, but anyway. And so if you had a red line in here, you would have another button. It would automatically recognize the red, and then you could click red. You could have green lines, you could have other lines, and that way you could have different feed speeds, and if you're using laser powers, for the different colors. And so that's a pretty handy thing to have, actually. Yeah, we may use that in the future for whatever reason.
Sure.
But then you're going to go send to Lasersaur, and as soon as you click this, it should leap into action. It converts the SVG or GXF or DXF to G-code, which I can show you some G-code in a second. Send to Lasersaur. Okay, if it doesn't do anything, usually homing it's a good idea. Oh no, it's just slow. Okay, so now I've clicked like multiple things. It's going to take a while to figure all that out.
So, but what's happening here, so we have the SVG file, and then when we hit send to Lasersaur, what does that do?
That should send all the G-code, right? It runs that little function, send _ G-code. It sends the whole pile of G-code to the Beagle Bone Black. Now Beagle Bone Black then sends it.
So that's made on our computer, right? That's made on the computer we're using as an interface. It converts, this is running a web app which converts it into G-code.
Yeah, the conversion is done inside the JavaScript applet. So like the SVG and the DXF file never actually leave your computer, which is kind of cool. And then, so the G-code goes to here, over the Wi-Fi, and then from here, it's like you can see it's sort of connected. It's got all these pins going through down to this lower board here. it streams the G-code commands one at a time to this thing here, this little computer, the 18 mega. And then that interprets the G-code. So like a G-code command will say, go to this particular X position and this particular Y position. Mm-hmm. And this sends the relevant number of pulses to the stepper motor drivers that convert into the power signal. And that goes out the cable here to the stepper motors. So these are the stepper motor plugs here, 1, 2, 3.
Okay, and then that Arduino over there is designed only for sensation and Z-axis movement, right? Z-axis adjustment. Yeah, okay.
Yeah, the other thing we want to do with it is to replace the manual control with automatic sensor. So it'll go like to a given fixed distance from the metal plate that it's cutting, and you can adjust the distance. So don't forget to unplug the battery. And so what just happened here is, I don't know if you noticed, it gives you a little status symbol up. They float up here in little bubbles. Mm-hmm. And you can go to logs here to see a record of those little bubbles.
Oh.
Now, one of the messages that came up said timeout, laser app server down. That means for some reason this Java applet is not communicating very well with the little Beagle Bone Black. And that's probably because the Beagle Bone Black crashed or something. It seems to do that. Now, so for future, because this video is for future developers, right?
Right.
So, the crashing, a good thing to look into would be the power supply. Because although it looks like a software issue, sometimes the power supply is such that like there's a ripple that's either too high or it drops to a relatively low voltage and something happens to the computer. And although the little LEDs are still on and say it's still working, the software has been crashed. Yeah. But it's because of the power supply, not because the software was crappy.
Oh, okay. So the drive board power supply, right?
Yeah, it would be the drive board power supply, 501 here too. And so like, I would probably look into that before blaming the software on the Beagle Bone, because it just started doing this relatively recently actually. So, we rebooted it, and let's do this little second connect here. And then, this two doesn't actually tell you when it's connected. If the Beagle Bone Black would like emit a little noise or something, then let's just do the home cycle. There.
You?
Okay, also for future users, something to watch out for is all these cables running out here. We have to do something about this sooner or later. The long-term solution is the track things, which I can show you on the Lasersaur. Do you want to see that?
Sure. Yeah.
Okay. Like, what do we want to do with this video here? We want to make it so people can turn it on and use it, or like this is a more extended documentation video?
Yeah, and I think like definitely we want to explain the things that are going wrong right now, the things that would require immediate attention to make sure that it doesn't break.
Yeah. So, okay, yeah, the cables are one of those things. So, okay, let's go see the Lasersaur. We'll see how they do the cables in the Lasersaur. If we can. Yeah, you can sort of, I don't know if the camera can see it, but I can see it.
Yeah.
You see this piece here? I'll show you first and then you can get it with the camera.
Sure.
Can you see over here? Like, can you see this thing here?
Yeah.
With the cables inside it? Yeah. Now you can see how that will move with the, if I move the carriage. You can see how it moves. Yeah. It's got those flexible cables and they're going to the stepper motors, and that prevents the cable from tagging.
Oh, that's nice. Yeah.
Yeah. So that's a common thing in CNC machines. We found it's a pretty good solution. So we can do it that way in the future. What we're doing right now is we've got elastics. Just took a piece of inner tube. There's a little piece of inner tube going on here. And that just holds it up. But you don't want these to get tangled because when this thing's moving, like it looks okay right now, but if it's in the middle of the table, it's a different situation. These cables hang down lower because they have more slack, right? And they can get caught on the next motor when it's moving. And they can get caught on these things. The way they're configured now, I've never had any catching. But that's why they're this way, because I used to catch and I changed it. So if something breaks or like you have to change it in the future, then you might run into that problem again. So the way I arrange in this way is that I move the table back and forth across in all different positions several times and like kept taping and wiring up the cables.
Oh, and just making sure it has enough
20 minutes
slack.
Yeah, it took me like 20 minutes to make sure everything was in all positions, had enough slack. It was like not going to wrap or catch.
Yeah.
So it's pretty good right now, but that's not going to be in the future. One good solution might be to have like wrap it all in elastic bands all the way up, all the way along, and have them like so they're quite well suspended from the ceiling. Stuff like that. Like, you're sure you could figure out some other solution in the tracks in the meantime if you wanted to, or maybe even it has a better cost performance ratio than the tracks do.
Yeah.
Because I don't know how much this cost. They're cheap plastic. But.
And with the stepper motors jamming and the emergency board for that.
Oh yeah. Okay, now the Lasersaur is supposed to have an emergency stop switch. That's just in here, but I don't know why. But it doesn't work for Jack. Like, it doesn't do anything at all. Like supposedly, whether it's not even connected right now, and if you close the two contacts, it should do something to stop. But even when it's running a program, it doesn't do anything.
It's connected to the Beagle Bone? Oh, I see.
Yeah.
Yeah. It's connected.
But the stop logic should be implemented by the Arduino.
Right.
So because that's lower level, so it responds faster.
Right.
But that doesn't work at all. There's also a pause button in the Laser app. Here, there's a pause button, but it takes like 5 seconds before it actually stops after you tell it to stop. Right. So that's like practically useless.
Process in your computer and then send to the Beagle Bone and then
but it takes forever.
Send the G-code. Yeah.
So that's my phone. Okay. So the emergency stop is instead to simply unplug the power supply to the stepper motors. That's very quick and effective. So the thing is that when you plug it back in again, the signal, the drive board may still be sending the signal to the stepper motor. So when you plug them back in again, it might start moving again, depending on what's going on. So you have to watch out for that.
What would you do to prevent that? Should you turn off the drive board?
Yeah, you can just turn the drive board off
before you plug that back in. Okay.
If you want to, yeah. Depends if you're testing something, you might want to do that because like it's convenient, which is actually not a small thing because it's going to take you 10 times as long to do everything otherwise, which means you'll get a tenth as much done, which means you're never going to get anything done. So, and the way it'll jam, there's two kinds of jams. There's one where the stepper motor is like, there may be a broken connection here or something, or there may be mud on the tracks. In one case I had someone had loosened, it might have been me, I don't remember, it was probably me, had loosened these bearings, like the nut here, that loosened, and that was causing it to jam on the other side. So I tried that one. Now, the other thing to watch out for, this is a more general documentation at this point, I think we've covered all the main stuff when it comes to safety and avoiding damaging the machine. As far as I can think of, there's nothing that's terribly dangerous about the machine. It doesn't move very fast and doesn't move with all that much torque.
I mean, it creates oxyacetylene torch.
Yeah, well, yeah, that's the thing. But like, yeah, obviously the torch for the, if you have that turned on, that's the most dangerous thing. You have to worry about explosions too from the oxyacetylene gas collecting in here.
Oh.
That's the real thing to watch out for. Because it takes you a little while to light it after it's turned on, right? So when you go to do the spark, you could get quite an explosion. You'll take your hair off and stuff.
Wait, it doesn't spark automatically? You have to...
Oh, no. This is just...
Oh my god.
Manual torch basically attached to the head here. It's, there's no gas control solenoid, there's no automatic ignition, there's nothing. There's a little lever here, this is for the oxygen lens. This is actually a machine torch. This is where they do it in the industry. Like, they don't have a gas control solenoid. The operator turns this thing on to pierce, and then they turn it back off again when they're done piercing. Like, so, like, although this looks like a cheapy, half-assed way of doing things, it's actually, they do things similarly in the industry because it is a pretty cost-effective way to do it, and you have to have an operator at the machine anyway to supervise it for safety and stuff. So, like, if they do one more thing or one less thing, it's fine. It's still, it's a huge, huge leap forward over having just a manual machine because this thing can do precise shapes and stuff, right? Which you can't do if you're just doing manually. So if you, the main thing you probably need to watch out for is that there's another stepper motor over here, right?
Should I come around?
No, you don't really have to. There's one over here, this one over there, and they don't home separately. What happens is the drive board taps them during the homing cycle, it tells the whole thing to move this way until it hits one or the other of the limit switches, and then both of them stop. And then it moves backwards by a centimeter or something, right? And thing is that this whole thing, one of the step motors can be further ahead than the other one, and so this entire thing can be skewed like this way. It can be rotated around the axis that extends vertically here, which is, if that's true, then your computer doesn't know that, right? So it's going to continue cutting. If you try to cut some parts when it's skewed like that, all your parts are going to be like suppose that's the rectangle there.
Skewed, yeah.
And then like you just bend the whole thing that way.
Yeah.
Then that's what your parts are going to pick. They're going to be skewed. So in order to prevent that, you want to make sure that you we're going to have to do something where what they do for the Lasersaur is they draw like some squares and stuff, and then you go and you measure the squares. So that way you know the machine's moving in approximately the right way.
Yeah, yeah.
So we can do that previously. You're going to have to continue checking to make sure that the after a homing cycle, that this is in the same position each time. Because that's the purpose of the homing cycle, is to get the step motors in a known position. So, but you're going to have to manually check until we fix this, that this step motor is in the same position that it usually is. There's a little mark here. We can make that real quick. There's a little mark that shows you where it should be. What else? I shouldn't really step on the rails like that because there's so much mud around here. I can get mud on the rails and cause a jam. And what else? Okay, the same deal on the other end.
I'll pause.